positive. A battery has a positive and a negative, right? And that's very important because if they're both positive and both negative, the electrons or nothing would want to flow between them. This is one battery. And you can imagine that this is the positive side and that's the negative side. Water, I obviously can't do it like that because the water will go out this one. So I'm going to put it next to each other. And in today's experiment, the positive and negative are actually on the same side of the battery. You know what a 9-volt battery is? Okay, so that's what a 9-volt battery looks like. And the idea is that there's too much of something on one side and not enough of something on the other side. Too much on one side, then it wants to go to the other side, right? But you need to have a difference of pressure. If there's no difference, it just stops. So in electricity, it's important that we think about electricity going from the top to the bottom, like that, okay? Like similar to a 9-volt battery, and there's 2 holes. No, they're actually not. Nails is you use a hammer. And these are called bolts. They're big. They have this big head, so we call it a bolt. Nuts. But don't eat them. They're not like those kind of nuts, okay? And a bolt and nut can screw together.
Why is it called a nut?
I have no idea. But it's called a nut. If we have, now these are iron. You know what iron is?
Iron Man?
Yes, exactly, just like Iron Man. Iron is one of the cheapest metals in the world, so many things are made of iron. And iron usually rusts. You put water on it and it will turn red and get yucky. So this one has a special coating called zinc. Screws are zinc bolts. Which one is positive and which one is negative?
That one?
You don't know, right? In fact, there is no positive and no negative because they're exactly the same.
It's both negative.
You could say that they're both negative. If they're both negative, you have these bottles here. This was the negative, the empty one, and this was the full one. If they're both negative, they're both empty bottles. How is the water going to flow? It won't. If they're both positive, both bottles will be full of water. How's the water going to flow? They're both full. It can't flow. So for electricity to work, you need something that's full and something that's empty. We are going to use water to make a battery. These are called colliders. Yes. Put that down here. So, these are all the components of a battery.
That's a not zinc.
Sorry?
That's a not zinc.
That's a not zinc bolt. You know what this is? Right, this is copper. Like grass?
Brass.
Brass, yes. You know why? Because brass is made of copper, but brass is not pure copper. It's a mixture of copper and something else. And brass has some good properties that copper doesn't have, so that's why brass is very popular. Negative?
No.
No. Are they both positive?
No.
No. So now,
Positive, negative.
exactly. How do we figure that
The
out?
shorter one?
No, the actual the size does not matter for electricity. At least
Color?
not for positive and negative. So this is how it works. H2O. We have an O atom, and we have 2 we have an H and an H. So you know that the smallest thing in the universe is a hydrogen atom. And the way it works is...
I thought plankton was
What?
plankton.
Plankton. Okay, so plankton is much, much, much larger than a hydrogen atom. Plankton is alive. It's alive, right? It grows. And these things are... Everything is made of these kind of
I
things.
thought there was something with a
Microscope.
it's a type of creature.
Chemistry is...
A type of plant.
You know Lego?
Yeah.
Okay. So chemistry is like Lego. It's the pieces, it's the actual individual pieces of Lego. And biology is taking that Lego and putting it together to create a living animal, right? So a plankton is made of pieces of Lego, pieces of chemistry. So these are the pieces right here. The pieces are not alive, but what you make from the pieces can be alive. This is the smallest thing in the universe, hydrogen atom. And
Including Pluto.
okay, Pluto is very big. Pluto's a planet. This is this is so small. It's in the air right now, but you can't see it.
I mean, is Pluto included in the universe?
Yes, but it's not included as a planet. So pretend that these are planets. Okay? They're very tiny planets. And a planet can have a moon, right? Earth has a planet, Earth has a moon. And there is one moon going around a hydrogen atom.
It
So-
looks like Saturn.
Yes, but I'm just drawing a fake line that shows you that this moon goes around like that. There's nothing in between. And oxygen has many moons. It has 1, 2, 3, 4, 5, 6 moons. Okay? Now, the way that chemistry works is they like to have 8 moons. Everything wants to have 8 moons or 2 moons. So this wants to have 2 moons, and this wants to have 2 moons, wants to have 8 moons. But it only has 6 moons. So what happens?
And the two doesn't combine into that, and
This thing
goes into the.
will visit
Oh.
the oxygen. And this moon will visit the oxygen. Now it's happy. It has 8.
But the H and E are not happy because they get their own.
Exactly. So they will complain and cry, and then the visitor will go back to the hydrogen and invite his friend as well.
Why don't the H's just go together? And the two.
They do. That's very clever. You can have 2 H's going together as well, and that's called something hydrogen. And that's usually hydrogen in the air by itself are usually glued together, 2 of them as pairs.
And
That's
now
very
the
true.
old sad because he only has 6.
That's right. So.
Now they're
And then there's the same thing here. This one will invite, this one will be 2 here and only have 4. They'll be sad and they'll be both happy. So this is what we call a changing relationship. It's like when you get married. If you stay with your husband's parents, they're happy for New Year's, Chinese New Year, but your parents are sad. So you go and stay with your parents for Chinese New Year, but then your husband's parents are sad. You keep rotating. Exactly, they keep rotating. So there's always a lot of visitors going back and forth, trying to make everybody happy. It is in water. There's a lot of electrons. These are called electrons. They're not called moons. They're actually called electrons.
How do you know that?
Oh, that's fantastic.
E L E C T R O N S.
Yes, electrons. 1 electron, which is almost impossible to find electrons. This is how electricity actually works. Because we can't see electricity.
It's
it's in the battery, and it's also in the wires.
It moves around and it gets squishy and it goes to the other side.
Yes, and what's moving around? Yes, it's the electrons. You put them in one end of the wire, and the wire's already full of electron. You push one in one end, and one comes out the other end. Not the same one as you pushed in, but another one that's already almost coming out. So it's like a bunch of balls in a tube, and you push in one ball at the beginning of the tube, and the ball's full of tubes, and the ball pops out at the other end, right? So that's how electrons work. And to make electricity, we want to encourage these electrons to go somewhere else, okay? So what happens is, copper.
It's too squishy there and it goes, and then when it flows, it goes to zinc and then it mixes together.
Yeah, who taught you that?
In the video.
Oh, you saw the copper is also a element. It's like a one of these things. Just like that and that, but they're different sizes. And the copper, thank you, just put that here. And the copper also has some electrons going around. And it wants more electrons. Most things want more electrons. So when the electrons are moving around here and they touch the copper,
But it gets too squishy.
well, it will get too squishy, but what actually happens is some of the electrons from the hydrogen and the oxygen will, this by the way means an electron, okay? They're going to get too squishy and they're going to be too many visiting the copper. What's that? Yeah, the zinc also wants electrons. And actually, zinc wants more, zinc needs more electrons than the copper. So what happens is zinc will attract these electrons in the water to here. There'll be more electrons here and fewer electrons here. If we use 2 zinc bolts, we would have zinc, and we would have the same number of electrons here and the same here. They would be balanced. So if we put a wire here,
And it touches it
which way would the electrons go if they were both zinc?
there.
They wouldn't go anywhere because there would be the same number on both sides. They'd be balanced. So no electricity would move. That's why it's so important to have one is different. So with copper, there will be fewer electrons here. And so when you put a wire like that, the extra electrons want to go and get out and go to the place with fewer electrons. That's how it works. 4 things. And we're going to be measuring the V, which is volts.
I remember the battery has I remember there's like a lot of
Volts. This is the volt range here. Now this is 0 volts. Sorry, so how many volts now?
0.
0, yes, exactly, 0 volts. Let's try. How about you put this together? So this is going to connect to wires. So we need one of those on each one.
Like that.
that to tighten it, you can use the pliers because they have a long nose that can get inside easily. So you take the pliers and you put them like that, and then you can turn the top part. Water can get in between the edges, and there's more water touching the metal than just a flat. This is a flat area, right? There's more water that can touch this than this because it's going in and out, in and out, in and out, in and out. Okay, try to put that inside the water. So what do we get?
Not sure.
But is it more than before? Yeah, so something useful.
The opposite way.
Yes, that's a good idea. So we're almost getting 1. It says 0.9 and it's positive. And
The
no,
other way. I want to try 2 on one side.
well, the electrons aren't going to flow through the wires if there's no difference. Now it's negative 0.8 or 9. Why does it say negative now? Which one is a positive terminal? Exactly. There's the positive terminal is the copper. With the red wire should be on the copper.
I want to try this.
Okay.
There's no electricity.
There's no electricity, there's no battery.
Oh.
Right? That's why we're going to all the effort to make a battery, because battery is not happening by itself. We have to. So we get about 1 volt, right? So what can we turn on with 1 volt?
A light.
Nope.
A watch.
Nope.
A solar.
A solar panel?
Yeah.
So that also makes power. It doesn't do anything. It just shows it gives power. So it doesn't turn on or anything. There's no light.
Shoes.
The
Sometimes
shoes?
they're like
Lights on
lights
shoes? Yeah. So those lights are called LEDs. And LED, 3 LEDs in one.
That's an LED.
There's 3 LEDs in there. You see the spike is here too.
Oh yeah.
And that's because there's 4 holes and it's easy to put things through. It's like sewing. Have you ever tried to sew clothes?
Yeah.
It's a single LED. Now you notice that you have to put these the right way. If it's the wrong way, it goes negative. The LED is the same thing. It only works the right way. And I put, this is the symbol for an LED. And because it only works the right way, it has a positive. To turn on an LED, you have to make sure that you put the positive and the negative. And which one is positive, which one is negative?
The positive one is
Any design LEDs is the shorter one is always negative. Short is negative, so long should be positive. But important is short is negative. So if we want to see if this is going to turn on, we should connect the short to which one? The zinc or the copper?
What's a zinc?
Yes. So we would do that. It's not very convenient though, right? There must be a better way to make the connections.
Open it?
Well, we're not going to do that because there's a much better way. And that is by using something called a breadboard. Now, you know board and bread. And usually you cut bread on a breadboard. You don't, this is too small to cut bread on, and it would be a bad idea. But we call it a breadboard anyways. And it looks like this.
Why don't you have another tiny piece of bread when you put it on the one?
You could, but if the bread crumbs get into the holes, then you can't plug anything in.
You can take it out.
It's very difficult. Exactly, you see the plus and the minus and on both sides. So this means that everything here is connected to plus. So this is connected to plus.
Oh yeah, it says on the line.
Yes. And if you want to connect it to negative, you would put it into
Oh
the...
wait, can I see the bread? Can you see it? It doesn't see it.
No, there's no words on that, just on this. So if you want to connect this red to the negative, where would you plug it in? Yes, you plug it in like that. And so you have these convenient lines. Everything here is negative, and everything on this line is positive. The same thing down below. You have a choice if you want them on top or down below.
You turn this.
You can turn that, sure.
Is it going to make my camera be weird?
No, it won't do anything weird. So right now, it can measure up to 20 volts. It will show, if it's 15 volts, it will show 1.5. And when it gets to 1.9, can it go 2.0? No, because it's based for 2.
What volts are there in a phone?
A phone? You mean like an old style phone you pick up like this, like, you know,
The one that you can fix certain.
oh, the mobile phone. So they all use the same kind of battery, and it's called a lithium battery, lithium battery. And they always have the same voltage. 3.7 volts. So my watch does not have a lithium battery, it has a 3-volt battery. We have see there's some letters on here. It's like a chess game. You can explain where each hole has a name. And the first one, all the holes here are all hole 1. So 1, 1, 1, 1, 1, 2, 2, 2, 2, 2. They're all in columns like this. And this way are rows. You know what rows are? When you go see a movie, you have to go to the right row for the seating. So this row is row A, and B, C, D, E, right? So if I plug this in here, where is it plugged in?
Row 9.
9?
Wait, 9
Can you read the number?
9. Wait, 2. It's 9.
So this is 9, okay? And this is, so it should be an E9. That's what I one end of the other. What we do is we want to plug this into the plus and the minus. Well, there's an easier way. If I look at our pile of wires here, we need to find a wire where one end is a socket and the other end is a plug. Plug is that one. Does it have one end is? Yes, that works. So would you like that to be positive or negative?
No. Looks like a bracelet.
Yes.
It's supposed to be a bracelet.
Definitely not. So, which one do you want to connect? Okay. great. Now, is that positive or negative? So, it's negative. So you should choose a negative. That's not negative. Yes, great, that's negative. Okay, so we got your final choice. But I think, yeah, that works. So you want green to be negative. You have to remember. How about putting it on the other side just to make them not so close together? Okay, great. So now all of this, these holes here are all negative, and all of these are positive. And one thing I didn't tell you that all of the holes this way, all the rows are connected together. So this A, B, C, D, E are all connected together. If I want one of these to be connected to negative, I put this. So that it connects this to this, and all of these, everything A, B, C, D, E are all connected together. So A, B, C, D, E on.
How could you tell that?
I used purple glasses. What was this? 14, yes. So now 14 is connected to negative, okay? And what on the other side? So we want this one to be above.
Higher one.
Yes, put it one up. There we go. Now what happens?
So high.
It's okay. And so this is all what? Positive or negative? Positive. So this connects this row to positive, and this connects this row to negative, right? So now we have negative and positive here. Now it's easy to connect the LED because we have the positive and negative close to each other. We have negative here and positive here. So do you know how to plug that in? So which side is negative? The light for the LED. Oh, that's too big. You're just going to jump across the bridge here. So the short one is negative, right? So yeah, so this is connected to that. So you can plug it in. No, because it's not connected. So this is connected here. That's all of this negative. So plug it in the last one. And the other side of the little thing here, that call this a river, okay, is the positive. So this guy should be on the positive. So pull it out. So these are very delicate. So don't try to bend it all the way around. Just turn the whole thing around. And make it close to the river as possible. So you don't bend the LED. There we go. We have the negative area, and then this little bridge makes all that negative, and this is positive, and this little bridge here makes all this row positive. So we connect the positive to the long LED pin and the negative to the short LED pin. So now there's a connection all the way from the negative wire and a connection from the positive terminal of the battery to here. And you can see there's nothing happening. No light turned on. Even though we know there's some voltage, because now you can put that into positive. You don't have to hold it. Put it into the positive. Alligator. You know alligators have big mouths, right? Up the back, yes. So what we're going to do, we're going to put one. Yes, and let's attach it here. Go. And now you can put that into the negative. There. So now you have 0.9 volts.
It's still not
It's actually not enough. We need to have more voltage. Now, this is 1.5. Is that enough to turn on the clock? No. So that's why we have two batteries, right? And the important thing is, can I put both batteries, like, if I put one battery, where's the positive? Yes. So if I put it in like that,
gonna work.
what's not gonna work?
Yeah. Put it the wrong way.
I should put it this way, put the positive and positive together?
No.
No. Oh, so I should put the opposite way. Why?
Because it's not gonna work.
Yes. So is it because in some situations you do want them the same way, and in others you want them the opposite way? When you put them the opposite way, it's like you're putting them like this. So you're putting the positive of one battery.
Like the bottom.
Yes, a bit like that for different reasons. Well, what happens here is here, how much voltage?
1.5.
Yes, and here, 1.5. And if it goes from 0 volts to 1.5, and I make this 1.5, then what is this? 0 to 1.5 volts, 1.5 volts to
3.
yes, very good. You are making the voltage higher by, this is called stacking the batteries or putting them on top of each other.
Is it really gonna work?
We have to figure out how are we going to connect these batteries so it's like stacking.
This is like too bad. Like
Volts, 2 terminals.
like
So how are we going to stack these batteries? How do we, this is a negative and it's a positive. How do we connect that? We want the negative to the positive? No, it's not working. You know why? 2 reasons. 1, there's no water. And 2, electricity will go from positive to negative, positive to negative. It'll just go around and around. It won't go out here. That's okay. This is just going slowly. So we need to put them side by side. And yeah, don't worry about that. That's already okay. So we need to take this off here, and we need to connect this to there. And where's the positive? Where's the positive battery? You're not really sure? Well, this positive is connected to this negative. From here to here, this is a 1.5 volt battery. This is a 1.5 volt battery. This is a 1.5 volt battery. Then from here to here, it's what?
3.
Yes, 3 volts. And then from here to here, yes, 4.5. And so if you want to have hundreds of volts, you just need to get lots of batteries, right? Okay. So that's what we're doing here. And you'll notice that this is the circuit. So this is going to go to the LED, the negative, and this positive is going to go to the LED. So we need to figure out this battery to go to the circuit and the negative of the first battery to go to the right side. good. It's still not lighting up. So this one is not. This is really water, yeah. The multimeter.
1.727.
Yes, 1.7. Is that more voltage than before? Yes. We need more voltage than that. And 1.8 volts isn't enough voltage. Well, this is a green LED. It's going to need a little more. The red LED needs less. So this is the red LED. This is a negative for the red LED, and this is the positive. So where would this positive go? And there's nothing to make it. Or where's the positive? Where does this positive go? Yeah, you put it anywhere there. Okay, and this is the negative. That's not, this negative isn't connected to anything. The negative is this one here. So where's that connected? Yes, good.
Hey.
So why don't we plug it into this side here? So oops. So to add this battery, we want to disconnect this so we can make a space to connect it up the next battery. Okay, great. And now it's 0 volts. Why isn't this battery doing anything?
I don't want it.
Oh. We have enough voltage with 3 batteries to make the light turn on, but there's something that's still missing, right? Because the light's so dim. And what's missing,
Another battery?
yes, but
More water?
that too. But these 3 batteries will make enough voltage. So if I turn off the light, if I pull out the light, it's going up to 2.1 volts. You see that? So the batteries are making enough voltage to turn the light very bright, but they're too small. So when you plug the light in, look at the voltage. Watch what happens to the voltage when you plug it in. See? It goes down, right? It means that the light needs a lot more electrons, and the batteries can't give enough electrons. We need bigger batteries.
How big?
Maybe 2 or 3 times. So what we need to do is make these batteries bigger. How do we do that?
That's
Let me show you how to make batteries bigger.
it.
I'm going to draw another battery next to the first one. And I'm going to connect this together. So now I'm connecting the negatives together and the positives together. And that is the same thing as one big battery. So the big battery is the negative and here's the positive of the big battery. So do you know that that's how we make big batteries? In fact, you know the Tesla cars, the electric cars? You know that electric car? Yeah. It uses thousands of small batteries like this. Just put them in. And inside are many, many small batteries. Inside. It can't do it. So we want to make a bigger battery, still has 4.5 volts, but just bigger. So it can, how do I say it? It's like, for example, the voltage is like how fast it goes. So for example, I'm walking this fast, right? Now, can I push a truck?
Yeah.
No, I cannot push a truck. A truck is an engine. And
It's like a truck. Like you're a giant.
I'm not a giant though. But a giant will walk as fast as me. So it's like I'm going 4.5 volts. He's going 4.5 volts. We both have the same speed, but do we have the same energy? He can push the truck, still 4.5 speed, but he has more energy. That's how battery works. We want to make the battery like a giant. Still the same speed. We don't want to put too much energy into the LED, but we want to have enough energy. So we need to make two batteries together. And there's two ways to do that. You can make them together like this. And now we have three 1.5 volt batteries. Or we can put them together another way, which is what we're going to do today. Because it's just a little fewer wires, and we're already having two, and the wires are getting a little complicated, right? So we're going to make, instead of three 1.5 volt batteries, we're going to make
One.
We're going to make two batteries, and each battery has how much voltage? Yes, it's the same thing. There's no difference. So we're going to make one 3-volt battery, we're going to make another 3-volt battery, and we're going to make them together a bigger 3-volt battery. Now, we only need 1, 2, 3, 4, 5, 6, 7, 8, connect 1.5, 1.5, 1.5. We're going to use 3 more. Here. So now we have to figure out how to make the connections. We want to connect 3 1.5 volt batteries to make one 3 volt battery. Why put it to this on the roof? It's important to me. So if you put it there, otherwise we're going to have problems. Don't worry about that. I think it's into here, and now you want to plug it into the other battery, other 3-volt battery. The other 3 volt. This is one 3-volt battery, and this is another 3-volt battery. You want to bring the batteries to connect together. This is one thing, and this is they're not together. We want to make one big battery. So we need to connect this battery together. Now you understand why there's 2 connectors? Okay, now where is the power? Yes, good. Now, this is the negative. This should go here. Okay, now the wires are connected. Now let's try the green one.
Why don't you go white one?
The white one takes a lot of there. You see the green one?
Yeah.
Turn off the light?
I want a blue one.
Well, we can try the blue one. If I turn off the red, oh yeah. See, what happens is the green one only works if there's no red. The red is easy to turn on. It will turn on and take all the power from the green. Okay, let's try the blue. But I think there's just not enough energy for the blue. You see the blue? Turn off the light. Oh, amazing! Yes, the blue. So to make, you know how to make white light? You need blue, green, and red together. Or together with white.
Okay, with everything.
Yes, you have to put everything on together. So I just put all these into the negative. We need more batteries.
Okay, 9 batteries to 10.
So the LED turned on a little brighter when we added a second 3-volt battery. Yeah. Okay, so now we have to make another 3-volt battery, just like the first one and the second one. There's no connection to the other batteries. Now we are making another 3-volt battery. You only need to connect the beginning and the end of the 3-volt battery to the other 3-volt battery. So the beginning and 1, 2, 3, 2 times.
This one? 1, 2, 3.
So now you have 1, 2, 3, 4. So you want this. No, don't change that. You need to do it. You copy it. Copy it one more time.
Copy it.
Yeah.
So I just do that.
Yeah, just like this. One more time. Can you see only the red light, or is there more than just the red light? Okay. Yes, there's the green. There's the blue. And the voltage without the third set is 1.63 volts, and I added, and it's 1.68. Okay, and this is turning off the third set of battery, and that's with the third set of battery. So there's a bit of a difference. So now, this is how much energy you get from 9 water batteries. Water batteries aren't that great, and we get more voltage if we use Coca-Cola. But we can use a real battery and see what happens to the LEDs. So all you have to do is connect these 2 wires to a battery. You know, you pinch this on under your thumb, this part here. Yes. Oh, whoa, what's happening there? Look at the difference now. I'm going to put in all 3. See? It's 2 point. Oh, this is still out. It's white here. There. Okay, it's almost white, right? There's 3 LEDs, 3 lights that are turning on now. And it's about 2.8, 2.9 volts. 2.9, there you go, 2.9 volts is good. These 3 batteries are connected one behind the other in like stacking, and that's called serial. When we connect 3 of these serial batteries with the positive and negatives together, you know what that's called? When we do it this way, that's an interesting idea. Yeah, it looks like paragraph these look like words, right? So serial is one sentence.
Serial's the title.
Word. No, this is the title. It's just doing it this way. So these are word is a sentence. Serial is a sentence, and 3 sentences is a paragraph, right? And when you put 3 sentences in a paragraph with the beginning and the end together. That is called So it's an interesting analogy you came up. It is spelled correctly. So these are parallel. When you put things in parallel, you always connect the negatives together and the positives together. And when you put things in serial, what do? Stack. And the positive is going to the yes. Positive to negative. So 2 negatives together. There's 2 negatives together and 2 positives together. Okay. This is negative to positive, right? This is called serial or parallel. Negative. Yes, it's serial. Negative, positive, negative, positive. What's this called? Negative, negative, parallel. Yes. And I can make a bigger battery by putting it into a box and have negative and positive. That's a bigger battery. Put more and more batteries together.
Why is this both?
Because it's sure it won't work. Example of what not to do to make a battery.
Can I put water in here?
Yeah, you put water in there and see if it works or not. Sure, you can do that.